Good afternoon and welcome to the fifth of 8 bite-sized KT modules. I'm Andrew Vermesh and today is about the difficult business of defining the problem we want to solve. Apollo 13 was a case in point. The starting message from Jack Swigert was, "Okay, Houston, we've had a problem here." And this was not untypical of the messages you receive every day from customers and colleagues. This episode, due in part to the extremely high levels of problem solving of all involved at NASA, ended happily. Not all major incidents do. This is about defining problems. We're going to look at separating different problems and why one object and one deviation is best. And you'll have a chance to try your skill or luck at a short problem later on. Now, where do we start? And the answer to this is always with data. Those who saw Module 3 will know that data is king here. Lots of people rush to discussing cause with a poor understanding of the data, and as a leader, you cannot afford to have your people do that. So do be very careful what question you ask first whenever there's a problem. And here's a question that people ask first quite often. Why is definitely not the first question to ask. If you give the impression that you're more interested in the cause than the data, causes are what you will get, full of assumptions, inventions, half-truths and diversions, and that will always delay the resolution. Here's an example. The latest release had a bug which stopped all transactions. Why was that? Well, the end-to-end process missed out one of the steps. Okay, well, why was that? Well, the processing diagram provided to the test designer was not complete. All right, well, why was that? Because the dev manager didn't review the diagram. Well, why was that? So people like to tell stories and they like to put together a story to present to us when we're discussing problems with them. But sometimes the information is not completely complete and correct. So we have to be very careful using the why question. It's not to say we can't ask it at all, but it's definitely not the first thing you want to ask. And certainly not before you've defined what the problem is that you're trying to solve. So let's have a look at problem definition and how to get to an effective definition. This is the starting point of everything. If we have something confused, then the data is likely to be confusing and lead nowhere, or to more possibilities than you can handle. So here's an example that I've worked on. The login problem. So my customer said, please help with this. We've had literally thousands of complaints about slow or impossible logins from users. We cannot find anything common to these. We've escalated the issue to our vendors, but so far all they've suggested to us is upgrade the software. That's a pretty common kind of response from vendors. Taking a look at a sample of the incidents, I saw the cause of their confusion immediately. There were multiple different login problems. Number one, when you click login and the timer wheel spins, but the login screen fails to appear at all. Number two, the login screen appears, but it's not possible to enter the password. That field is frozen. Login problem number three, having entered the password, the screen freezes, and so on. There were at least 12 different things happening, and as it turned out, 8 different causes. The perfect storm. So this is an extreme example, but relevant. You must not treat similar looking issues as the same until you have looked at the detailed and confirmed that they are the same. So effective definition, as we see on screen, has 2 components to it that are really important. What's the object that's observable that is malfunctioning? This could be a process, it could be a machine, it could be a report, it could be anything you can imagine. And what's the observable deviation? In other words, how has the performance of this thing departed from what's expected? What is it doing that's wrong that you don't expect it to, or what is it failing to do that it should do in normal circumstances? And often the examples we get are things like the one above that diagram. Database is slow. That's not enough. We need a bit more detail. What exactly is it that the user of that process is looking at that's performing badly? Oh, well, it's the retrieval of the customer records. Okay, and what's wrong with that? Well, it's taking 15 to 30 seconds versus the normal 1 or 2 seconds. So as soon as you've got a very precise description of what is the component, function, or product that's going wrong and what exactly it's doing that's not according to plan, then we have a good problem definition. And the key principle here is MOPS: measurable, observable, precise, and succinct. This should not be an essay. It should not be an impact assessment. Now, impact assessment is absolutely vital. We should always have an impact assessment. That's absolutely vital. But it is not an investigative datum. What the impact is on the users is not part of the investigating process where we're looking for the causes. It's something we need to manage for sure. But when we want to guide the investigators, we want to say, this specifically is the problem that we want you to solve. So with that in mind, I'm going to get you to look at an example here and get instead of have a look at these examples and tell me which is the best problem statement. So we'll open the vote in just a second, but have a read of those. Customers are unable to get online account balance for savings accounts. Multi-wheeler 17, tire 6 left, shows a 27% deflation every day. Network switch has all these things going with it, and customers in Paris areas 416, 17 not able to send video or picture messages this morning. So let's start voting for which one of these you think is the best and clearest problem statement. While that's going on, we had a question, which is an interesting point here. The 5 whys system, which eventually aims to get to root cause. And 5 whys is a good thing to do. The principle here is that for most problems, if you ask why 5 times, you will get to a root cause. However, that is only provided that each response to each why is complete, clear, and valid. And often it isn't. So I think that's important. So we've got the third question, the third example marked as thing. Let's have a look at if we can see it in the votes, see which one. There's a lot of people here who have been on KT classes at some point, and you have remembered very well what should be going on. So we've got votes here. This is a little bit like Ask the Audience, isn't it? There's 4 options here. Which one do we think is the right answer? Oh, it's changing now. Ooh, let's have a look. We'll stop voting with 52%, 45% for number 2, 31% for number 3, 22% for number 4, and 0% for the first one. Let's have a look at what the answers are. So, in the first case, customers are not able to get an online account balance for savings account. The object here is not precise. We're not saying, is it all customers? Is it some customers? Which customers? We ought to be a bit more precise here with the problem statement. The second one does have a clear object. There is a vehicle, number 17, and there is the tire on that vehicle, and there is the fault with that tire. So we have a very precise object, and we have a very precise description of the symptom. Now, why not the third one? Well, there's too much here. Remember MOPS. The fourth part of this is succinct. We actually want the thing to be a summary of what it is that needs investigating, what item and what fault. The other stuff is valuable information. You should certainly have it in your case management description somewhere. But the stuff about traders being unable to complete trades, very relevant, but not for the investigation. That's more to do with the impact assessment, which we use to manage the impact rather than find the cause. And then finally, we have more than one symptom. Video and picture messages is more than one symptom, and unless we are certain that those are feeding off exactly the same system, we should not lump them together. So well done those of you who went on the class and still remembered that we have one object, one deviation in a good problem description. Now, if you have the suspicion there may be two things going on here, then we should create two separate cases. We've got customers in Paris area 4 with a video message problem, customers in Paris area 16 with a video message problem, 17 video message, and then the same repeat for the picture messages. Keep them separate until we establish conclusively that they are linked. So let's have a quick look here, and no further questions at this time, but please throw them in. Now, another exercise. Let's try and define the problem that you see in the next exercise. It's a very short one, and if you go to the attachments and have a look at the problem case study, very short Word document there, and see if you can read that quickly and tell me what you think is the problem statement in this case. Customer payment has been credited to wrong invoice. We don't know that yet. That may be the cause, but it's not a problem statement. Let's try and improve on that. Got any other votes for this? Can we make the object more precise? What is it here? We'll not do this for too long because we are limited to 15 minutes with these webcasts. Anybody else got a thing here? Customer received invoice after they paid. Okay. What else have we got here? Okay, we've got a couple of answers there. So let me give you what the KT answer would be here. This is the answer here is the object is a process. It's the invoice credit process, specifically for invoice B773. So invoice credit process for B773 fails to credit account, and fails to credit account would be the symptom. Now, it's very easy when we're using everyday language to get a little bit less than precise. But actually, if we're going to start an investigation in good order and actually conclude it in good order, we do need that precision. So the crediting process for invoice B773 failed to credit the customer. Now, let's move on just quickly in our last few moments of this session. Why should we bother with any of this? What is the point of this extreme precision? Well, you know what, if you're an Apollo astronaut, you really did need extreme precision, otherwise you would have been dead. And those sad folks in Challenger and the other disaster perhaps could have benefited from some extreme precision in problem solving prior to those horrible, tragic launches. But why bother? Any process, including problem solving, is only as good as the quality of its individual steps. Things that start well tend to go better. If you allow any investigation to start with a lack of clarity about what the problem is that you're trying to solve, it tends to go badly. The problem statement can, of course, change through the investigation. When we start off with a gearbox that skips the third gear, then we investigate a bit and we find there's a misalignment in the clutch, and then we find where the bolt is loose, and so on. We will change the problem statement until we find the cause of the loose bolt and stop the problem permanently. Even so, clarity about the problem to be solved at every stage of an investigation saves lots of time and money. On average, 26% of your time and money. Now, look, you can do your own samples with this. If you go to your case management tool, whatever it is, or your quality management tool, and have a look at all of the things that have been reported there, you can come up with a number for when you had a good title at the start, what did it cost you? When you didn't have a good title at the start, what did it cost you? So you can come up with your own number and think about what you're going to do about that. But it's definitely worth pushing your folks with this object in deviation concept as far as you possibly can. So what now? Well, if you're going to get any benefit from this, I'd say read the attached book chapter. There's a chapter in attachments that you can take home. And at your next review meeting, it might be worth looking at the recent problems logged in your case management system. That may be today, that may be tomorrow, maybe next week. Have a look at how many problems have a clear object and a clear deviation, and then try and find out what is the cost in human effort and material when you do start in the wrong place. And I'd be happy to hear your ideas and thoughts on that subject at any time at avoidable@Kepner-Tregoe.com. You can also find me later and also at some of the upcoming public sessions, which you can find at this URL that you can pick up later. Now, what's happening next? We will have influencing decisions on Thursday. So if that's a subject that's dear to your heart or something that you want some thoughts or tips about, then see you at the same sort of time on Thursday. And it's been lovely having you on the call so far. Look forward to seeing you Thursday if you're coming. And as always, do tell me how you're getting on at Andrew on Twitter or on LinkedIn. Thanks very much, everyone.